Okay, basically there's it's a standard error. It's actually the mean of means divided by the square of the number of observations. So that is in the notes that was emailed to you. I hope you got that all. Okay. One question that was asked yesterday, and I've just thrown this in, so it's a little bit of an aside. The question was asked, how do you know how many samples you need to take? It's actually very simple but complex. Okay. That's actually quite simple. I have a sample. What we need to do, I don't know how many samples you need to take. So I'm going to measure the yield of wheat plants. Do I measure 10 plants? Do I measure 20 plants? Do I measure 50 plants? I've got no idea. So what I could do is I can go into the field and I can measure the yield of 10 plants. That's a starting point. So let's assume I've done that here. Okay, this is length. This is not yield, but the same principle. So I'll measure the samples. I'll take a sample of 10 plants. I'll work out the mean. I'll work out the variance, the standard deviation and the variance. Okay. And what have I done here? 5 samples, 4 degrees of freedom. Okay. What have I done there? Okay, I'll check it out in a minute. Okay. Now basically, N is the number of samples I need to take. Okay. T is the value that comes out of the book that I need to work on. Now I've got the wrong one out of the book here. Okay, because it should be 9 degrees of freedom. So I've obviously I changed something and I didn't change it correctly. Okay, but you got the idea. You go and look up that T value in the table. Okay. And that let's assume it's 2 or it was 2 in the previous one that I measured. Okay. So you take T squared times the variance. Okay. You divide it by D squared. Now D squared, I want to work on a 95% probability. That's what we normally work on. That's why I've been going on about 95% of the population. Okay. So you'll notice in the table they call it 0.05 instead of 95. We talk about 95, but it's 0.05 is actually the correct terminology. And I have that squared because I want a 95% limit. And there I have the mean squared. Okay. And I work that out, and it works out to N is equal to 26. So in other words, I'm 16 units short on my sample. So if I want to reach a level of accuracy, I need to actually take 26, make it 27. You can't take half a sample. Okay. And I will then be within a reasonable estimate of the minimum number of samples I need for an accurate evaluation of whatever I'm measuring. Okay. So it's fairly simple. And again, you can see everything is based on the T value, the standard deviation, and the level of accuracy you want. Okay, whether it's a 95% or 0.05 probability or whatever the case may be. Probability of greater than. Okay.
I don't know, it's just your notation, but I mean your standard deviation is 23, yeah? Yeah. You're using, is it 4.85? Is it just the type?
It's a standard deviation squared.
Yeah, okay, well then your notation's confusing.
Why?
Well, if you're using S squared and S squared at the top, that's a bit confusing for people.
Yeah, well, it should come down to the same thing there. Your standard deviation times standard deviation is the same thing. Don't worry, it's the time of day. But, right, okay. So that is the number of samples. Okay. So I'm going to leave this part here and let's go into something a little bit more practical. Now what have I done here? Okay. So that is the basis on which a lot of the analyses rest. And that's why I've spent a lot of more time on it than I actually anticipated. But hopefully we are there.